Good morning. Can you hear me?
Mm-hmm.
Can
Good
you hear me?
morning, Sir.
Yeah. Okay, good. Our class is going to start on now, and it's going to be on probability. That is unit 8. So we are going to go through the book, and if you have any questions, you may ask. So if you have any questions along the line, you can either type it or you can just put on your mic and talk. Okay, so now I should believe all of us must um, understand probability. The probability is whenever you have a probability, your answer is always must always be from 0 to 1. Now, when it is 0, it means that that probability can never occur. And when it is 1, there's 100% chance of that event occurring. And most of the time, it is hardly 0 or it is hardly 1. It's most of the time between 0 and 1. It's most of the time between 0 and 1. And we define probability of an event, probability of an event as the number of events, that is NE, number of events over the number of sample space. Number of events over the number of sample space. Now, we define the sample space as the number of possible outcomes, and the event is the number of the actual outcome of the event. Now, if we look at this table in table activity 10.1, now you'll find out that it's a table talking about um, adults and children, and it's talking about adults who watch TV more than 10 hours, and who watch TV less or equal to 10 hours. You see that where we have 75, 75 is simply an adult who watches TV more than 10 hours. And 125 is also an adult who watches TV less than or equal to 10 hours. Then this 200 simply signifies the number of adults. Then the 150 here simply signifies a child who watches TV greater than 10 hours. And this 50 signifies a child that watches TV less than 10 hours. Then this 200 signifies the number of children. And these 225 here simply represents the number of um, people. It can be adults, it can be children, but number of human beings who watch TV more than 10 hours. And this 135 here represents the number of human beings who watches TV less than or equal to 10 hours. And please, the number at the corner here is always sample space, no matter the question that they ask you. The number below here, that this 400 is always the samples, which is the number of possible outcomes, which we call the sample space. So, if you look at the question, what's the probability? What is probability of a person selected is an adult. So, probability that the person is an adult. How many adults do we have? From the table, we have 200 adults. So, it's going to be 200 probability of adults will be, so the event is adults. The event is the number of adults. Is the number of adults, which we know from the table that number of adults is 200. Then we know that the sample space is 400. 400. So the probability of an adult, when we cancel out, we are going to have 1 over 2. And please take note that this 1 over 2 is the same as 0.5, which is between 0 and 1. Now, in the same way, the next question is asking for probability of selecting a child. Now, from the table, we know that the number of children there are also 200. So, probability of a child will obviously be 200. Will obviously be 200 over 400, which is the same as half. Please, any questions so far? Any questions so far? Okay, good. Then the next one says this: what the probability of a person selected watches TV greater than 10 hours a week and is an adult? Now, watches TV than 10 hours a week and is an adult. We can find it here. It's only 75 people who watch TV greater than 10 hours and also an adult. So probability will be 75 over 400. Is at times most of you will go and say 75 over 200, which is wrong, because the sample space is always 400. There is a tendency of most of you going to say 75 over 200, which is going to be wrong. So 75 over 400, please. Now, the last question says, what is the probability of a person selected watches TV less than or equal to 10 hours a week and is an adult? Clearly, we can see that a person watching TV less than 10 hours a week and is an adult. We are having 125 people. So it's going to be 125 over 400, which we can easily cancel out to be, let me see, always try and cancel out to the lowest number. Here we are going to have 25, I think, over 80. Then you can still cancel out to be 5 over 16 or something like this. Then you get the answer. So that is the small theory of probability. So as I have defined for you, probability is the number of events over the sample space. So if you look at the notes here, say that probability is a branch of mathematics that calculates the likelihood of an event occurring. That is the chances of an event occurring, and the chances is always between 0 and 1. When it is 0, that means that the chances of the event occurring can never happen. And when it is 1, then it means the event and the chances of the event occurring is 100%. So it simply means that when the probability is getting closer to 1, it means that there's a chance that the event is going to occur. And when the probability is getting closer to 0, that means that there's a least chance of the event occurring. There's a least chance of the event occurring. So the notes is here, you can read it. As I said, the probability is always lies between 0 and 1. 0 and 1. So let's go on. Here we look at these are some experiments that can occur. I mean, for instance, if you toss a coin, there are two chances of what can happen. You can either have a head or a tail. But now, if you toss a coin twice, there are 4 possibilities. That the sample space is 4. You can either have a head, a head tail, a tail head, or a telltale. So the sample space is 4. When the coin is tossed twice, then it's 2 times. But when you toss the coin once, the sample space is only 2. You can either have a head or you can have a tail. And when you toss a coin 2 times, you can have 4 possibilities. Either a head tail, a tail head, or a tail tail. And now when somebody gives birth, there are 2 sample spaces. The 2 samples possibility samples remember that sample space is the possibility of an event occurring. It is either a boy or a girl. When you write an exam or a test, there are only the sample space is only 2. You can either pass or fail. And when you roll a dice, which obviously have 6, the sample space is 6 because the number of possibilities that can occur is 6. So you must take note of how we determine sample space. So if I may ask, any questions on a sample space, how we determine the sample space? Now, if you can look at example 10.1, you see the probability of a 7 on a normal die, which has 6 faces, is 0. So this is when you can have, as I said, when the probability is 0, it simply means that the event can never occur. And a very good example is when you roll a dice and you get a 0. When you roll a dice, you will never get a 7 because there is no 7 on a die. So that probability is 0. And that event can never occur. And that this is that okay, we are saying that when we throw a die 1 to 6, and when we throw a die, and when we throw a 1, 2, 3, 4, 5, or 6, the probability is equals to 1. So definitely, if you want to obtain 1, 2, 3, 4, 5, 5, 6, that is 100% possibility that once you throw a die, you are going to have either 1, 2, 3, 4, 5, and 6. So that is when you have 100% probability. So when the probability, and all that here is trying to say is that when the probability is 0, it means that it will never occur. And when the probability is 1, there's 100% chance that it's going to occur. There is no chance that it's going to fail. Then when the probability is between 0 and 1, it means that it can either occur or it will not occur. That is when the chance comes inside of it occurring, it not occurring. Please, any questions? Please, any questions? Okay, let's look at this example. Say that the table below lists the results of a student survey pertaining to favorite ethnic foods. Each student choose only one type of ethnic food for a survey. So here we have different types of food: Italian, Chinese, Japanese, Thai, Mexican, and others. So if I may ask, what will be the sample space here? The sample space will be 15 plus 20 plus 3 plus 4 plus 30 plus 10. Because when you select any food, that is the possibility that you will choose one of them. So here, if you can check, our sample space NS is going to be 82. Our sample space NS is going to be 82. Please, who doesn't understand why our sample space is 82? Are there any questions? Why our sample space is 8, or is there any question of why the sample space is 82? So now it says that find the probability that a student's favorite food is Chinese. So there are the number of events is 20 over the sample space, which is 80. So we are going to have 1 over 4. 1 over 4, which will become 1 over 4. Then the next one says that students' favorite ethnic food is Mexican. Now we have 30 Mexicans. So the number of events is 30 and the sample space is 80. So we are going to have 3 over 8. 3 over 8. Please, any questions there? Yes, no Monday.
Sir, in the sample space is 82, so why are you putting 80?
Oh, it's 82. Oh, I'm sorry. I thought it was 80. Sorry. Please, it's 82. I'm so sorry. Thank you very much. I'm so sorry. I thought it was 80. I'm so sorry. It was 82. Okay, sorry. Thank you very much. Please, it's 82. So you can simplify with 82. So it cannot be 1 over 4. It cannot be 1 over 3. Thank you very much, no Monday. Thank you. Now let's go on the next. Now we can look at the other examples there. I should believe that you can look at them. You can look at them. So I want us to look at the questions and some of the questions in the book. Let me see. Okay, here, yeah. Okay, there are some questions here. Okay, so let's look at activity 10.1. It says that from a pack of cards, one card is drawn. What's the probability that it is red? It's a jack, and it's a queen or a spade. So, and please, to answer these questions, must be very conversant with cards. I'm hoping that the question is going to give you what do you call it? An accurate picture of cards. But you must be very conversant with cards. In So we are talking about these normal cards, which are 52. You know those cards. Okay, can you hear me now? Can you hear me? Aaron, can you hear me? Okay, good. Okay, good. So we are talking about the normal cards, which is 52. I hope you know these cards. Do you know of these cards? These normal cards, which is 52. Do you know of them?
Yes, we do.
Okay, good. So you find out that so we have what are the names of those cards? Who can tell me? What are the names of those cards?
There are hearts, spades, diamonds, and flats.
Good. And how many hearts are there? How many are the hearts?
13.
There are 13 hearts. There are 13. There are 13 hearts. There are 13 spades. Each of the four is 13, 13, 13. Have you seen that? Okay, good.
Yes.
And each of the 13, how many pictures do we have?
Pictures.
Yes. Remember that each of the cards have got pictures. Remember that each of the cards have got pictures.
12.
Yeah.
How much? Remember that each of the cards have got pictures. Queen. Am I correct? Am I correct? Am I correct? They have got a jack, a queen, and what? can help us there? Okay, no. Okay, let's go on. Okay, the first question. So we know that we have 52 cards. So that means that our sample space is 52. Are we saying that? Our sample space is 52. So now the first question is that what's the probability that our card is going to be red? Out of the 52 cards, how many red cards do we have? Out of the 52 cards, how many red cards do we have? We have 26. Good. So that means that we are going to have 26 over 52. 26 over 52, which will simply be half. Good. Then, what's the probability that we are going to have a jack? Out of the 52 cards, how many jacks do we have? A jack is a picture. So how many jacks do we have? We are going to have 4 jacks. Each of the 4 cards has got a jack. Have you seen that? Each of the 4 cards have got a jack. So our answer is going to be 4 over 52. Is any questions on the first 2 answers? Number A and number B. Any questions there? Please, number A and B. Any questions there? Number A and B. Any questions there? Okay, good. Now the next one says that what the probability that we have a queen of spades. A queen of spades. How many queen of spades do we have? How many queen of spades do we have? 52 cards. A minute. We are having only one queen of spades. I was saying that because the spade has got only one queen. You all agree? The spade has got only one queen, so the answer will be 1 over 52. 1 over 52. Please let us remember that all our answers is between 0 and 1. Let us all notice that. Please, any questions? Any questions, please? Please, any questions? Okay. In the absence of no questions, let's go on. Let's go on. Okay, good. Now, our next one says this. It says that the probability of a plane being late is 2 over 3. What is the probability in fraction, decimals, and percentages? I think this one you can do it yourself. So let's leave number 3 because it's not probability, it's just you dividing and at times dividing and multiplying by 100. So let's go to the third one. It says that a bucket contains 3 bottles of apple juice, 2 bottles of orange juice, 6 bottles of tomato juice, 6 bottles of tomato juice, and 8 bottles of water. If Kyra randomly selects a bottle, what the probability that she will select a drink other than water? That is a very good question. So, first of all, if I may ask, what will be our sample space? What will be our sample space? What will be our sample space, if I may ask? What is going to be our sample space? Who can tell us our sample space? Our sample space is going to be 19, which is 3 plus 2, which is 5, plus 6, which is 11, plus 8, which is 19. Now, it says that if Sarah randomly selects a bottle, what the probability that she will select a drink other than water? Now, if she will select a drink other than water, that means that she will select either orange, represented by O, or orange juice, or tomato juice, Please, in probability, anytime we use or is for addition, In probability, anytime we use or simply means addition. So now we will say probability of orange juice, which are represented by O, or tomato juice. Everything, because the question says that what's the probability that she will select um, um she will select a drink other than water. So if she will select a drink other than water, that means that she's going to select either an orange juice or a tomato juice. So it's going to be probability of an orange juice plus, because or means addition, plus probability of tomato juice. Now, probability of an orange juice is going to be 2 over 19. And probability of a tomato juice is going to be 6 over 19. So in all, we are going to have 8 over 19. At times, this method can be cumbersome. If, let us say, we are talking about 10 or 11 items, you cannot do all these things one. It becomes very cumbersome. Everything. So there is an easier way of also getting the answer. Everything that. Let us talk. It's and sorry. And we also have apple juice. I didn't see the apple juice. Sorry. Or apple juice. Please, I'm so sorry. I never saw there was also apple juice. Ability of apple juice. So it will be let's start again. I'm so sorry. I didn't see that there was apple juice. So it means that we are going to have probability of what do you call it? Apple juice, or orange juice, or tomato juice. What's in that? Then it's going to be probability of apple juice will be 3 over 19. Then the probability of tomato juice will be 2 over 19. The probability of tomato juice is going to be 6 over 19. So in all, we are going to have 11 over 19. 11 over 19. You see that? Can we imagine that these things, they were of them? You see that? It was going to be cumbersome for you to do all these things one by one. Have you seen that? So you also have to note that total probability, I'm just giving you another alternative and easier solution. Consider. So we have to know that total probability is always equals to 1. It's always equals to 1. You see that? So here the question says probability that he chose any juice other than water. So you can subtract probability of water from the total probability. So to be 1 minus probability of water we see here is going to be 8 over 19. 8 over 19. So it says that probability of choosing anything in this in the juices, in the bottle of juice, except water. So if I know that my total probability is equals to 1, then I will just subtract, I will just take out probability of water, which is 8 over 19 from 1. Then I will also get 19, 11 over 19. So that is a more easier way of answering this question if you have got so many variables to deal with. Please, any questions on the two answers? Please, any questions on the two answers? Please, any questions on the two answers?
No, you can carry on, sir.
Okay, good. Then let's go on. Let's go on. And let's look at the next one. It says that there are 37 possible numbers on a roulette wheel. That is from 0 to 36. Remember that because of the 0, that's why we are having 37 outcomes. Because of the 0. What is the probability that if I win, if I bet on 8? If I bet on 8, what will be the probability? You can tell us. You can tell us. What the probability of if I bet on 8, I will win? You can tell us the answer. You can tell us the answer, please. Yes, it's going to be 1 over 37. Okay. Then the next one says that what's the probability that I win if I bet on 17, 18, 19, and 20? It will obviously be 4. It will obviously be 4 over 37. Then the next one says that what is the probability? What is the probability that I win if I bet multiple of 3? You can tell us the answer. Multiple of 3. What's the probability that I win if I bet on a multiple of 3? You can tell us the answer. You can tell us the answer. Let's see the answer. Okay, it said 12 or 37. Okay, let us see how many multiples of 3 do we have from 137. First one is 3. The next one is 6. The next one is 9. Then we have 12. Then we have 15. Then we have 18. We have 21. We have 24. We have 27. We have 30. We have 33. We have 36. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why do you say 12? Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, it's 12. So we have 12 over 36. Sorry. Thank you very much. 12 over 37. Yes, thank you very much. Any questions? Our answer is 12 over 37. Any questions there? Any questions there? Okay, good. Now, our next one, we have, how do I put it? It says, what's the probability that if I bet or win, if I what's the probability that I win if I bet on 30 and above? What would be the answer? 30 and above. What's going to be the answer for that one? 30 and above. What's going to be the answer for that one? You can tell us. 30 and above, we have 30 up to 36. So we have 7 numbers there. You all agree. So it's going to be, yes, over 37. Thank you very much. 7 over 37. Thank you, Monday. Now, the next one says that an even number. An even number. How many even numbers do we have from 0 to 36? An even number. How many even numbers are we going to get from 0 to 36? An even number. How many even numbers are we going to get from 0 to 36? Is how much? You all agree we are going to have
18.
18 even numbers. Good. So it's going to be 18 over 37. It's going to be 18 over 37. Okay, good. Now the next one says that a jar contains 48 black balls, 23 blue balls, 76 yellow balls, and 14 green. Okay, it's marble. Marble is drawn at random. What's the probability that it's not green? First of all, what will be our sample space? 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 161. Good. So, probability that it is not green. Please, most of you will go this way. If it is not green, then that means that it is probability of it being black, or I would say black is BL, or blue, or blue, or yellow. Have you seen? Or yellow. Then you go like this. 23. Oh, sorry. You go like this. 48. Remember that all means addition. So you go like this. 48 over 161 plus 23 over 161 plus 14, sorry, plus 76 over 161. Now, when we simplify this, you will get your answer to be 147 over 161. You get the answer to be 147 over 161. But as I have told you, this method, at times, it will look cumbersome if the items are many. So now they have told you that probability of not green, probability that it is not green, you know that total probability is 1. So it will be the simple probability of not green. Probability of not green, not being green, can simply be equals to 1 minus probability of green. 1 minus probability of green. See, you get the same answer because the probability is 1. So it will be 1 minus probability of green is 14 over 161. 14 over 161. 14 over 161. Then you are going to have the same answer, 147 over 161. 147 over 161. 147 over 161. Please, any questions there? Please, any questions? Okay, in the absence of no questions, let's look at the last one. Now, the last one says that the test showed that 2,000 light bulbs made in a factory are made in a factory. The test shows that 2,000 out of 2,000 light bulbs made in a factory, 25 were found to be faulty. If I pick a light bulb random, what is the chance that it is faulty? It is simple and straightforward. It will be 25 over 2,000. It will be 25 over 2,000. 25 over 2,000. It's as simple as that. Because the sample space is 2,000 and 25 were faulty. 25 over 2,000. But when you finish, always try and simplify it with your calculator so that you can find the correct answers in the multiple choice. Please, any questions? Okay. In the absence of no questions, let us go to activity 10.3. Oh, okay, number 8 is okay, and please, it's a request for us to repeat number 8. So you see the probability of not green. So if you have a blue, a yellow, a black, a blue, a yellow, and a green marble, then you are asked to find the probability that you didn't choose a green. That means that you either choose a black. That means that you either choose a black, a blue, or a yellow. You either choose a black, a blue, or yellow. So probability of not green will be either a black, which is 48 over 161, or a blue, which is 23 over 161, which is 23 over 161, or a yellow, which is 76 over 161. And I also said that the easiest way of doing it is to know that the probability is equals to 1. So you simply subtract probability of green, which is 14 over 161. Then you can have your answer. 14 over 161. You can, all the two will give you the same answer. That understood? That understood? Okay, good. So let's go on. Now, let's look at activity 10.3. Now, the first one says that a survey was taken on 10 classes, 30 classes at a school to find out the number of left-handed students in each class. to find the number of left-handed students in each class. Find the number of left-handed students in each class. A minute. Okay, let's go on. Find the number of left-handed students in each class. The table below shows the results. So here is the number of left-handed students. And here shows the number of left-handed students. So, and here is the frequency of number of classes. Please, do you understand the table? Do you understand the table? Please, do you understand the table? Because when a question is given in the table form, the first step is that you must understand the table. That you must understand the table. So, do we understand the table? Okay. So I assume, okay. So it says that a survey was taken on 30 classes at a school. Find the total number of left-handed total number of left-handed students in each class. So 0 left-handed students was found in only one class. 1 left-handed students were found in 2 classes. 2 left-handed students was found in 5 classes. 3 left-handed students were found in 12 classes. 4 left-handed students were found in 8 classes. And 5 left-handed students was found in 2 classes. Monday, does it make sense to you? Monday, does it make sense to you? Okay, good. So now, the first question is that find the probability that the class has 2 left-handed students. So, 5 classes have got 2 left-handed students. Have you seen? And remember that the number of classes is 30. See, so 5 classes have got 2 left-handed students. So, probability of 2 left-handed students in the class will be 5/30. Does the answer make sense? 5/30. The next one says that what is the probability that the class has at least 3 left-handed students? The class have at least 3 left-handed students. What would be the answer? At least 3 left-handed students simply means that 3 or more. So what would be the answer? Number 2, 1.2. What is the probability that a class has at least 3 left-handed students? So 3 means that it will be 12 plus 8 plus 2. So that means that our answer is going to be 22/30. Do you all agree with that? Do we all agree with that? So 1.2, the answer is 22/30. Do you all agree with that? Or who doesn't understand why it's 22/30? Or who doesn't understand why it's 22/30? Or who doesn't understand why it's 22/30? So we can go on. Can go on. Okay, no, then let's go on. Now, let's look at the next question. It said that a chart below gives the number of suicide estimates in the United States for a recent year by age, race, black and white, and sex. We are interested in possible relationships between age, sex, and race. We will let suicide victims be our population. Okay, so let's look at the table. Okay, good. So here is race and sex. So white male, we have 210 who committed suicide, and between 1 and 14. Between 15 and 24, we have 360. Between 26 and 60, we have 3010 in that order. I hope the table is understood. Or who doesn't understand the table? Who does not understand the table? Okay. So I assume all of you understand the table. Now, the first question is that find the column for suicide individuals over the age of 64. So that means that you are going to add everything here and subtract from the total. So when you add everything here, you subtract from 22,085. So when you do it correctly, you are going to notice that the first one is 4870. Here will be 4870. 4870. Then you please let me write it here. White male is 4870. The space is too small. 4870. Then um white female is 890. 890. Then black male is 140. Then black female is 20. Then all others is 100. And obviously the total is going to be 6,020. Now, so that will be the first one. Then the second one says that and the row too, we can find them to be Did I find the rule for all races? The rule too, we can find them to be 1 to 14 is 0. Is 0. When we subtract, we get 0. Then remember that we add we will add all this and subtract from this total. We add all this and subtract from this total. Add all this, subtract from this total. Add all this, subtract from this total. Okay. So what do you call it? 15 to 24 is 210. It's going to be 210. It's going to be 210. Then 25 to 64 is 460. It's 460. Then over 64 is 100. Then our total is 780. Is 780. So the next question says that find the probability that a randomly selected individual was a white male. And the number of white male is 2,000. Remember that here is always the sample space. See that? So white male, there were 2,000, 2,050, 2,050, 2,050. And that will be the number of events. And the sample space, sorry, it was in 2050, sorry. And the sample space was 29,000 and 29,760. 29,760. Then you divide and find your answer. You divide and find your answer. Now the one says, next one says, find the probability that a randomly selected individual is a black female. Black female, we can see black female here to be 330. So it's going to be 330 over 330 over 29. 330 over 29,760 over 29,760. 760. And last one, it says that find the probability that a randomly selected individual is black. Please know that when it says black, we have black male and black female. So with this, with the probability, you are going to add one. You are going to add 1670. 1670 plus 330. All over the sample space, which is 29,760. Then we find our answer. Okay, good. So please, any questions there? If there are no questions, we are quickly going to move to if there are no questions, we are quickly going to move to how do I call it? We are quickly going to move to mutually exclusive events. Now, mutually exclusive events is very simple. When two events are mutually exclusive, that means that the events cannot happen at the same time. If two events are mutually exclusive, the simple meaning is that the two events cannot happen at the same time. If it cannot happen at the same time, it means that probability of, let us say, if the events are A and B, the probability of A and B is 0. If the two events cannot happen at the same time, it means that the probability of A and B will always be 0, because the two things cannot happen together at the same time. So if we use these things of a card, you are asked to draw a card from a deck of 52 cards. Have you seen? And you draw a spade, which will be just 1/30. You draw a heart, it's 1/4. Now, drawing a spade or drawing a heart are mutually exclusive. Have you seen? Because you cannot draw a spade and draw a heart at the same time. Have you seen? If you have cards and you pick one card, you cannot draw a spade and draw a heart at the same time. So it makes the two events mutually exclusive. It makes the two events mutually exclusive. So please, you have to know that when two events are mutually, the normal, and how do you call it? Normal formula for mutually exclusive events or independent events is probability of A or B. Probability of A or B. Probability of A or B is, let me just write it properly. When we have probability of A or B, probability of A or B, probability of A or B, A or B is always equals to probability of A, probability of A plus probability of B probability of B minus probability of A and B. A and B. This is the general formula. Probability of A and B. Forgive me for my writing. Probability of A and B. But when the events are mutually exclusive, I'll write it ME. When the events are mutually exclusive, then we must know that probability of A and B is 0. Probability of A and B. Probability of A and B is 0. When the events are mutually exclusive, probability of A and B is equal to 0. In that case, for mutually exclusive events, probability of A and B is equal to probability of A plus probability of B. Because probability of A and B equals to 0 for mutually exclusive events, because probability of A and B cannot happen at the same time. Please, any questions? Please, any questions? Okay. So if in the absence of no questions, we can go on. We can go on. So please put it in mind that when the events are not mutually exclusive, probability of A and B is not 0. The events, the probability of A and B is equal to 0 if and only if the events are mutually exclusive. probability of A and B is 0 if and only if events are mutually exclusive. Now, let's look at the first question. Now, what's the probability of throwing a die what is the probability of throwing either a 2 or a 6 with an ordinary die? Now we find out that when you throw a die, you cannot get a 2 and 6 at the same time. That means that the two events are mutually exclusive. Have you seen that? So the probability will be only probability of A, probability of a 2, will only be a probability of a 2 and probability of a 6 because the two events are mutually exclusive. So probability of a 2 and a 6 cannot happen, so it's 0. So we are going to the probability of a 2 is 1/6. Probability of a 6 is 1/6. It's 1/6. Then our answer is going to be equals to 1/3. 1/3. Okay, good. Now, so that is the theory behind mutually exclusive events. Mutually exclusive events. So now let's look at these questions on. It says that a card is drawn from a deck of 52 cards, defined as defined events. A, the card is 2 or a 3 or a 4. B, the card is 7 or a 8. C, the card is a picture card. Now, the first question is asking what the probability of a and what the probability of a B and what the probability of a C. Now, probability of a it says that it's either a 2 or a 3 or a 4. Now, the question is that are these three events mutually exclusive? Are these three events mutually exclusive? Who can answer me? Who can answer me? Now, you find out that we have 4 twos in a card, we have 4 threes in a card, and we have 4 fours in a card. Have you seen? And these events cannot happen together. So 4 plus 4 plus 4, we are going to have 12 cards. We have 12/52. Then 7 or a 8, we have what do you call it? 4 sevens and 4 eights. So the second one, we are going to have the answer to be 8/52. The first one, the answer is 12/52. Then the second one, the answer is going to be no, let's look at the second one properly. Oh, sorry. The probability of A. The second one is the probability of B. Probability of B is 7 or 8. 7 of A, we get 4 sevens and 4 eights. So it's going to be B is going to be 8/52. Then the next one says that probability the card is a picture card. Now, how many pictures do we have in each of these cards? I think the pictures are for each of the sets. We have got 4 pictures. So 4, 4, 4. I should think we have got No, sorry, I got 3 pictures. So 3, 3, 3, we are going to have 12 pictures. So you're going to have 12 over 52. Please, any questions there? Okay, good. Then the next one says that next one says that ability of A or a B or a C. Now, first of all, we must check whether these 3 events are mutually exclusive. Are these 3 events mutually exclusive? No, you cannot pick A and B and C at the same time. So probability of A, B, and C will simply be equals probability of A plus probability of B plus probability of C. This is going to be 8 over 13. So as I told you, when the events are not mutually exclusive, probability. Any questions, please? Very good. Now, in the absence of no questions, let's look at examples here. Let's look at the examples that a minute. Yeah, this example. That is it. Okay, good. So it says that a card is drawn from a fair pack of cards. What the probability of drawing a black card? Okay, we know that one is going to be 26 over 52 because there are 26 black cards. So I don't think that one will be a problem. What's the probability of drawing a black card or a picture card? Good. Please, are these 2 events mutually exclusive? A black card or a picture card? Now, the first one, probability of picking um, drawing a black card, black picture card. How many black pictures do we have in a set of cards? Please participate. How many black picture cards do we have in a set of cards? I want the picture. You know that the cards have got pictures. Listen. So we are talking about black pictures. That are black and they are pictures. Peter, we have a jack, a king, and a queen. Am I right? The pictures are a jack, a queen, and a queen. So how many black cards do we have of those? Of those, how many black do we have? Tell me how much. Let me see. Good. We are going to have 6. Have you seen that? So the first answer is going to be 6 over 52. 6 over 52. Now, what's the probability of drawing a black card or a picture card? Who can tell me the answer? What's the probability of drawing a black card or a picture card? Number A is 6 over 52. So number B, what is the probability of drawing a black card or a picture card? What's the probability of drawing a black card or a picture card? Who can tell us the answer? A black card or a picture card? Who can tell us the answer? Um, First of all, okay, 8 over 13, 6 over 52. Okay, now let's see what is happening here. First of all, you have to note and ask yourself. First of all, let me ask: are the two events mutually exclusive or not? Or not? First of all, that's the first thing you have to check. Are the two events mutually exclusive or not? Who can give me that answer? Are the two events mutually exclusive or not? Who can help us with that answer? They are mutually exclusive because there are black cards that are pictures. So that means that you can pick a black card that's also a picture. So that means that the two events are not mutually exclusive. Saying that they are not mutually exclusive. Everything because we define mutually exclusive as events that um, two events are mutually exclusive. Those two events are not happening at the same time. And here, these two events can happen at the same time. You can pick a black card and you can pick a black card that's also a picture. You see that? So that means that these two events are not mutually exclusive. Please, who doesn't understand why they are not mutually exclusive? Who doesn't understand why they are not mutually exclusive? Who doesn't understand why they are not mutually exclusive? Who doesn't understand why they are not mutually exclusive? Okay, everybody, they are not. They can't be mutually exclusive. They are not. Because the two events can happen at the same time. Have you seen that? So that means that there is a probability. That means that if they are not mutually exclusive, and it simply means that you will have probability of A and B. Probability of A and B. Sorry, A or B. Let me say A is black card and B is a picture card. Have you seen? Is going to be equals to um probability of A plus probability of B minus probability of A and B. A and B because the events are not mutually exclusive. The probability of A is probability of black cards. How many black cards do we have? We have 26, 26 over 52. Got that 26 black cards. Two. How many picture cards do we have? We have 12 pictures in a card. So we have 12 over 52. Then how many black cards do we have that are also pictures? There are 6 of them. So it will be minus 6 over 52. Do you understand this? Do you understand this? then we can calculate our answer. Please, is that understood? Okay, can you tell me where you don't understand it? Because you don't understand that the events are not mutually exclusive. You don't understand the formula. So you don't understand how I got my numbers. Just give us an idea exactly where the problem is. Moseko, can you give us um, an understanding of where you have an issue? I got my numbers from a cars. We have 52 cars. Have you seen that? And out of 52 cars, we have 26 of them being black, 26 of them being red. Then um, we have 12 pictures in the cars. Have you seen that? Out of the 12 pictures, six of them are red, six of them are six of them are red, six of them are black. Probability of Moshe, say probability of A and what? I can't see the next one you have written. Probability of A and B. Probability of A and B is probability of the card being black and a picture at the same time. Who's in that? Probability of A and B is the card being black and a picture at the same time. Who's in that? And probability of a card being black and a picture at the same time is 6 out of 52. Does it make sense to you? Does it make sense to you? Okay, good. Thank you very much. Please, any questions again? Okay, so we can go on. Now, the next one says this. A man throws a die numbered 1 to 6. The probability in fraction decimals. Okay, no, I don't think this one you can do it yourself. Okay, no, let's answer this. Consider a man throws a die numbered 1 to 6. What's the probability in fraction decimal and percentage from getting multiple of 5 or a multiple of 3? So we ask ourselves, how many multiples of 5 do we have? It's only one, which is 5. We've seen that. Then, how many multiples of 3 do we have? It's only one, which is 3, from numbers 1 to 6. Have you seen that? So, if I may ask, are these two ends mutually exclusive? So, how many multiples of 3 do we have? Sorry, it's 2. Because we have 3 and a 6. They are all multiples of 3. A 3 and a 6. The multiples of 5 is only one, which is 5. Let me put it well. Multiples of 5, we have only one. Multiples of 3, we have only 2. So let me ask, are these two events mutually exclusive? Are these two events mutually exclusive? Yes or no? Are these two events mutually exclusive? Yes or no? Are these two events mutually exclusive? Yes or no? Can somebody answer me? Good. They are mutually exclusive because they cannot happen at the same time. Have you seen that? So if they are mutually exclusive, then it means that um probability of A or B, probability of A or B, A or B, or B will simply be equals to probability of A plus probability of B. There will be no minus probability of A and B. Why? Because the events are mutually exclusive. The probability of A, let's say probability of getting a 5 is 1/6. Probability of getting a multiple of 5, sorry, it will be 1/6. The probability of getting a multiple of 3 is 2 of them. It will be 2/6. And we can just add them together. Is that clear? Okay, good. So let's look at the next one. It says that in a class of 40 students, 8 are in a drama club and 12 are in the arts club. If a student is selected at random, what the probability that the selected student is in the drama club? Obviously, 8/40. It will be 8/40. Drama club will be 8/40. Then the next one, neither in the art or drama club. Now, those in the art and the drama club are 20. So those who will be neither in the art or drama club will also be 20. So it's going the second one that's 20/40. With 20/40. The second one, the answer will be 20/40. Any questions there? Any questions there? Okay, good. And let's go to the next one. It says that a bar contains 4 white counters, 6 black counters, and 1 green counter. What's the probability of drawing a white counter or a black counter? Therefore, you have to ask yourself, are these two events mutually exclusive? Probability of green and black, is it mutually exclusive? Probability of green or black, is it mutually exclusive? Is it mutually exclusive? Probability of picking a green or a black, is it mutually exclusive or not? Who can tell us? Probability of a green or a black, is it mutually exclusive or not? It is mutually exclusive. So it will simply be the sample space 4 plus 6 plus 1, we have 11. So it's going to be 4/11 plus 6/11. Any questions there? Now, a white counter or green one is also mutually exclusive. Probability of a white counter or a green counter. is going to be, and what do you call it? 4 over 11. 4 over 11 plus 1 over 11. Is any questions there? Okay, good. And let's look at the next one. It says that of cards, one card is drawn. What's the probability that it's a king or a queen? What's the probability that it's a king or a queen? You can tell us the answer. Here too, we can see that the events are not mutually exclusive. So, because you cannot pick a king and a queen at the same time. You cannot pick a king and queen at the same time. So, probability of a king or a queen probability of a king or a queen is going to be we have 4 kings, then we have 4 queens. So it will be 4. We know the number of cards is 62. So it will be 4 over 52 plus 4 over 52 plus 4 over 52. Then we are going to get 8 over 52. Okay, good. Please, any questions there? Please, any questions there? Okay, then we can go on. Now, the next one says that Gerald is dealt a hand of 13 cards. 5 are hearts. Please, the heart, is it red or please help me here? Those who know cards. The heart, is it red or black? Is the heart red or black? When you pick cards, the heart is red. Thank you. Okay. Then we have the diamond. Is it red or black? Diamond, is it red or black? The diamond too is red. Okay, good. Then we have a club. A club. So obviously a club will be black. I've seen that. And it will be black. Good. Please, you must know these details about a card. You must know these details about a card. So now let's look at the first question. It says that probability of now it says that the cards are 30. So that means that your sample space is 30. But it's not talking about general cards. It's just talking about a set of cards or a selected card. So your sample space is 30. Your sample space is 30. Now, the first question is this. It says that probability of picking a hat or a spade. Probability of picking a hat or a spade. The first thing you must check is that a hat or a spade, is it mutually exclusive? Yes, it's mutually exclusive because you cannot pick a hat and a spade at the same time. And from the question, the number of hats is 5. So we have 5 over 30. 5 over 30. Then the number of spades is 3. So it will be plus 3 over 30. Plus 3 over 30. Then we have our answer. Then the next one is the probability of picking a club or a diamond. Probability of picking a club or a diamond. A club is we have only one club, so we have 1 out of 30. Then a diamond. A diamond is 4 of them, so we have 4 out of 30. And please, we are doing it this way because um, all these events are mutually exclusive. That is, it cannot happen at the same time. Have you seen? Now, the next one is taking a red card. Now, we know that hearts and diamonds are red cards. Have you seen that? And we have 5 hearts, 4 diamonds. So that means that we are going to have 9 red cards out of 30. Out of 30. Please, any questions there? Okay, good. Now, the next one, we go like it says that a card of a card is drawn from a deck of 52 cards. Let the event A and B be a card is faced a card is a face card. If it's a face card, that means that there's a picture. And B, the card has point values less than 6. The card has point values less than 6. So now the first question is the first question is um find probability of A. Find probability of A. The card being a face card. How many face cards do we have? How many face cards do we have? Obviously, we have 12 face cards. Thank you very much. It will be 12 over 52. It's going to be 12 over 52. 12 over 50 because each of the 4 cards have got a queen, jack, and a king. So 3 times 4, each of the 4 sets of cards have got a queen, a jack, and a king. So 4 times 3, we are going to have 2. The probability of B, a card has point value less than 6. That means that each of the cards have got 1 to 5. Each of the cards have got, is it 2 to 5? I've got 2 to 5, ne? So that means that each of them have got 2 to 5. 2 to 5. Which will be 2, 2, 3, 4, and 5. And so they have got 4 of them. 1, 2, 3, 4. And remember that we have got 4 sets of cards. So 4 times 4 is going to be 16. 4 times 4 is going to be 16. So we are going to have 16 over 52. 16 over 52. 16 over 52. And the next one is the probability of A or B. The card is either a face card or a card with a number less than 6. Please let us remember that. Let us remember that minute. Let us remember that always you must check whether the events are mutually exclusive. And yes, the probability of A or B, they are mutually exclusive. It cannot happen at the same time because you cannot pick a picture card and a card with a number less than 6 at the same time. That means the probability of A or B, probability of A or B, probability of A or B is going to be equals to probability of A plus probability of B. It's going to be equals to probability of A plus probability of B, which will be 12 over 52 plus 16 over 52. Because the events are mutually exclusive. Is any questions? Okay, so you have to look at the examples yourself. I just want us to go to the main question because our time is not very much. Now, the first question says that fair dice, one colored white, the other one colored red are true. So we throw 2 dice. And the first question is that the probability that the score on the red die is 2 and on the white die is 5. Now, each of the probability is going to be 1 over 6. Let me see. So in probability, if they use n, whenever you see n is multiplication. Remember that I said or is addition and is multiplication. So whenever you see n is multiplication. Whenever you see or, whenever you see n is multiplication. And whenever you see or is addition. You must take note of that. Whenever you see n is multiplication. Whenever you see or is multiplication. So the probability of picking 2 on the red die will be 1 over 6. The probability of picking a 5 on the white die will be also 1 over 6. So we are going to have 1 over 36. Now the score on the white die is 1, on the red die is even. So here too is n. So it's going to be multiplication. It's n. It's going to be multiplication. So on the white die is 1. On the white die is 1. It will be 1 over 6. And on the red die is even. There are 3 even numbers. Times 3 over 6. And you can find your answer. Please, any questions there? Please, any questions there? Please, any questions there? Okay, good. Now, the next one says that the score on the white die is either 3 or 5. Or means addition. Let me see that. So the score on the white die is either 3 or 5. Or means addition. So 3 will be 1 over 6. 5 will be 1 over 6. So we are going to have 2 over 6, which will be equals to 1 over 3. 1 over 3. Any questions there? Any questions there? Okay, good. Now let's go to the next one. Let's go to the next one. Now, next one says this. The score on the white die is either 3 or 5, and the red die is 4. Now, we know that on the white die is either 3 or 5, and the red die is odd. So 3 or 5 is addition. So we are going to have 1/6 plus 1/6. That is the or 3 or 5. Then we have n. So this one will be in brackets times, and the red die is odd. So n is multiplication. There are 3 odd numbers, so it will be 3/6. Then you are going to have 1/3 times 1/2. Then you get your answer. And then your answer. Now, the next one, it says that both dice show 4 or 5. Both dice shows 4 or 5. Both dice is showing 4 or 5. So 4 or 5, that means that the red die is showing 4 or 5, and the white die is also showing 4 or 5. So we are going to have for the red die, we are going to have 1/6 plus 1/6. Then times the white die, which is also going to be 1/6 plus 1/6. And we can get our answer. Please, any questions there? Any questions there? Okay, if there are no questions, please, you must go and do the rest of the questions yourself. But the key thing is that always remember that when you are asked to find probability of A or B, please always check whether the events are mutually exclusive or not. If they are mutually exclusive, always subtract the probability of A and B from it. And so if they are not mutually exclusive, always subtract the probability of A and B. But if they are mutually exclusive, probability of A and B is always 0. Exactly. So I am going to look at the other questions on your own. If you are having any questions on any of them, you can just send me a message privately, and I'll definitely respond to you. So in the absence of no questions, I would like us to bring the class to an end, unless you have any questions. Unless you have any questions. Okay, so in the absence of no questions, let's bring the class to an end. Thank you very much for attending, and good luck in your exams tomorrow. Thank you.